We had to actually go through and prove something that was theorized in 1937.
Before we can even begin talking about Microsoft's quantum chip, we need to understand what quantum computing is and why it's such a big deal. Most of us are familiar with the traditional computers we use every day: laptops, smartphones, desktops. They all rely on binary systems, meaning everything is either a 1 or a 0, a yes or a no. This is the basis of classical computing. Quantum computing, on the other hand, operates on a completely different level. It uses quantum bits, or qubits. Unlike regular bits, which are in one state at any given moment, qubits can be in multiple states simultaneously. This is thanks to a phenomenon known as superposition. Now imagine trying to solve a massive problem, like factoring large numbers or simulating molecules for drug discovery. With classical computing, you're limited by the number of bits and the speed at which your processor can handle them. Quantum computers, however, can process exponentially more data because they leverage the properties of quantum mechanics, things like entanglement and superposition. So, what's so special about Microsoft's quantum chip? Well, unlike traditional quantum computers that rely on superconducting qubits or trapped ions, Microsoft is exploring a different approach. Their quantum chip is based on a concept known as topological qubits. Topological qubits are unique because they are more stable than other types of qubits. This makes them less prone to errors caused by environmental factors like temperature and electromagnetic radiation. If we're going to build a large-scale, fault-tolerant quantum computer, stability is essential, and topological qubits might be the key to making that happen. Microsoft's quantum chip is still in development, but the company's investment in this area could potentially revolutionize computing as we know it. However, there's more to the story than just making faster computers. The implications of quantum computing go beyond anything we could have imagined a few decades ago. Now let's start to bridge the gap between quantum computing and multiple universes. The concept of parallel universes, or the multiverse theory, is rooted in quantum mechanics. The idea suggests that there may be multiple versions of reality, each existing simultaneously but in separate dimensions or timelines. These universes could contain alternate versions of us, making different choices or living out different outcomes. At first glance, this idea might sound like science fiction, but it's actually a theoretical framework that has been gaining traction among physicists. There are various interpretations of quantum mechanics, and one of the most famous is the many worlds interpretation, MWI, which was proposed by physicist Hugh Everett in the 1950s. The many worlds interpretation posits that every time a quantum event occurs, the universe splits into multiple versions, one for each possible outcome. This means that every decision we make, every measurement we take, and every possibility that could play out actually creates a new universe in which that outcome becomes reality. So how does this all tie into Microsoft's quantum chip? Well, here's where things get interesting. Quantum computing, as we know, operates based on quantum principles. These computers process information in a way that seems to defy classical logic, and in doing so, they tap into the weirdness of quantum mechanics. Now, what if, just what if, this new technology could be more than just a tool for faster computation? What if the quantum computer's interaction with qubits somehow allowed it to communicate with other realities in the multiverse? We've seen a variety of theories pop up over the years about how quantum computers could potentially open doors to other universes. In one of the more mind-blowing ideas, some physicists suggest that the behavior of qubits in superposition could allow quantum machines to bridge gaps between parallel realities, giving us access to alternate timelines or even new realms of possibility. Now, let's delve into the more speculative side of this theory. Could it be possible that Microsoft's quantum chip, by harnessing the power of topological qubits, is actually interacting with these parallel universes in ways that we don't yet fully understand? Some scientists and theorists are beginning to speculate that the computational power of quantum systems might not just be limited to processing information. Instead, they could be tapping into the very fabric of reality itself, potentially gaining access to dimensions beyond our own. Imagine a scenario where a quantum computer using entanglement and superposition begins to process data that isn't just coming from our own universe, but from multiple, possibly infinite, universes. The data could be coming from alternate versions of events, from different outcomes of decisions made in parallel realities. This sounds like something straight out of a sci-fi film, but it's not entirely out of the realm of possibility according to some quantum physicists. These are, of course, theories, wild and speculative ideas that could change everything we understand about reality. So, what could this mean for the future? If quantum computers, like Microsoft's topological qubit chip, are able to communicate with multiple universes, it would open up a whole new frontier of exploration. We could, in theory, tap into resources, information, and even technologies from these alternate realities. Imagine being able to access scientific breakthroughs or inventions that exist in parallel universes. What if we could learn from the mistakes or successes of alternate versions of ourselves? Could quantum computing become a tool not only for computing, but for understanding and manipulating the very nature of existence? Let's take it a step further. If we were able to send data back and forth between universes, could it lead to communication with other intelligent life forms or civilizations that exist in parallel timelines? What if, in a different universe, a version of humanity had already solved some of our most pressing problems? Climate change, energy production, disease. If we could somehow communicate with these universes, it could be the key to accelerating human progress and innovation. Of course, there are massive ethical questions that would arise if quantum computing were to allow us access to other universes. How would we ensure that we didn't cause harm by interacting with these realities? What if our actions in one universe had unintended consequences in another? Additionally, if we were able to communicate with other civilizations, how would we manage that interaction? What if these alternate versions of ourselves were far more advanced or far less developed than we are? How do we navigate such a powerful and unpredictable tool? There would need to be frameworks and safeguards in place to prevent the misuse of such incredible power. And we would need to think long and hard about the potential consequences of altering the fabric of reality itself. Looking forward, it's clear that quantum computing is still in its infancy. The idea that Microsoft's quantum chip might somehow be communicating with multiple universes is at the moment just a speculative theory, but the potential is there. We've seen enormous progress in quantum technologies over the last few decades, and as we continue to push the boundaries of what's possible, the line between science fiction and reality may begin to blur. For now, we can only wonder what lies ahead. Could quantum computers unlock doors to other dimensions? Could they bring us closer to understanding the true nature of reality? Only time will tell. Before we dive further into the mind-bending possibilities of quantum chips and the multiverse, let's take a closer look at the evolution of quantum computing. As we know, the history of quantum computing has been a journey filled with groundbreaking discoveries and astonishing technological advances. The concept of quantum computing emerged from the very basics of quantum mechanics, a field of physics that deals with phenomena at the atomic and subatomic levels. In the early 1980s, physicist Richard Feynman proposed that traditional computers wouldn't be able to simulate quantum phenomena effectively. He suggested that quantum systems themselves might need to be harnessed to perform simulations. This marked the birth of quantum computing theory. Over the years, a number of key figures in the field, such as David Deutsch, Peter Shor, and Love Grover, began developing theoretical algorithms to show how quantum computers could outperform classical ones for certain tasks. Peter Shor's algorithm, in particular, demonstrated that a quantum computer could factor large numbers exponentially faster than classical computers, which was a breakthrough with far-reaching implications for cryptography and data security. By the early 2000s, quantum computing was still largely confined to the realm of theoretical research. But with the advent of technologies like superconductor-based qubits and trapped ion qubits, we began seeing the first tangible progress toward quantum machines capable of performing real calculations. The next logical step was to develop quantum computers that were more than just theoretical models or lab experiments. Companies like IBM, Google, and Microsoft have since stepped into the arena, each focusing on their own approach to quantum computing. IBM and Google have made strides with superconducting qubits, while Microsoft's focus has been on topological qubits, as we mentioned earlier. As we explore the evolution of these systems, it becomes clear that the implications of quantum computing go far beyond just faster calculations. The very nature of the technology could allow us to access different realms of existence, alternate universes, if you will, by tapping into quantum mechanics' more unusual phenomena. How Microsoft's quantum chip works. Microsoft's approach to quantum computing through its topological qubits is one of the most unique and ambitious among all the players in the quantum space. The topological approach aims to solve one of the biggest challenges facing current quantum computers: error correction. As you might imagine, quantum systems are incredibly delicate. Superposition, the ability of quantum bits to exist in multiple states at once, is a fragile phenomenon. Any interference from the external environment, such as temperature changes or electromagnetic radiation, can easily disrupt the qubits and introduce errors. Microsoft believes that the use of topological qubits will help overcome this challenge. Topological qubits are not as easily disturbed by their environment as other types of qubits. This makes them more stable and fault-tolerant, two essential characteristics for scaling up quantum computers. The key to topological qubits lies in their use of exotic particles called Majorana fermions. These particles are theorized to be their own antiparticles, and they exist in a form of quantum state that's particularly resistant to error. By encoding quantum information in the braids of Majorana fermions, Microsoft hopes to make topological qubits the key to building large-scale, reliable quantum computers. But while the technology is promising, there's still much to be done before we see widespread practical applications. Current quantum computers are still in the early stages of development, and even the topological qubits Microsoft is working on are a long way from being fully realized. The next few decades will likely see rapid developments in quantum technology as companies and researchers race to unlock the true potential of quantum computing. Quantum computers and the multiverse, a new frontier. So how does this quantum chip tie into the idea of multiple universes? This is where the theoretical and speculative aspects of quantum computing really come into play. For years, physicists have speculated that quantum mechanics might not just be a tool to understand the behavior of particles in our own universe, but could provide insights into other dimensions and parallel realities. When we talk about the multiverse, we're referring to the idea that our universe might not be the only one that exists. Instead, there could be a vast array of universes, each with different laws of physics, outcomes, and timelines. These universes might be parallel to our own, existing alongside it in a higher dimensional space, or they might be entirely separate with no overlap. One of the most prominent theories in support of the multiverse is the many worlds interpretation of quantum mechanics, which we discussed earlier. This interpretation proposes that every quantum event creates a branching of the universe into multiple timelines, with each timeline representing a different outcome of that event. For example, consider a coin toss. In the classical world, the coin will either land heads or tails, and that's the outcome. But in the quantum world, the many worlds interpretation suggests that when the coin is flipped, the universe splits into two separate branches, one where the coin lands heads and another where it lands tails. Both outcomes exist, but in different parallel universes. Now let's take this concept and apply it to quantum computing. Quantum computers, with their reliance on quantum mechanics, process information in ways that traditional computers cannot. When a quantum computer performs a calculation, it doesn't just work through one possible solution at a time. Instead, it explores all possible solutions simultaneously through superposition. This means that, in a sense, a quantum computer is tapping into multiple outcomes or parallel timelines at once. What if, just for a moment, we entertain the idea that these parallel timelines might not just be theoretical? What if, through the processing of quantum information, a quantum computer is somehow interacting with these parallel universes? Could it be possible that the computations performed on a quantum chip are pulling information from multiple realities, or perhaps even sending information back to them? This idea stretches the imagination to its limits, but it's a concept that some scientists and theorists are seriously considering. Quantum computing, in this light, becomes more than just a tool for faster calculations. It becomes a window into the very fabric of reality, potentially allowing us to communicate with and explore other universes. Entanglement and its potential to bridge universes. One of the key phenomena in quantum mechanics that could potentially be used to bridge universes is entanglement. This is a phenomenon where two or more particles become linked in such a way that the state of one particle is instantly related to the state of another, even if they are separated by vast distances. Entanglement has been described as spooky action at a distance, a term famously coined by Albert Einstein, who found it difficult to accept. The basic idea is that once particles become entangled, measuring one particle will immediately affect the other, no matter how far apart they are. In the context of quantum computing, entanglement is one of the most powerful tools for processing information. When qubits are entangled, they can perform computations in parallel, drastically speeding up certain processes. But what if entanglement could go beyond our universe and affect other realities? Could entangled particles be connected to parallel universes in ways that we don't yet understand? This idea, while speculative, is rooted in the very principles of quantum mechanics. If quantum systems can interact in such mysterious and non-local ways, perhaps quantum computers have the potential to manipulate or communicate with different versions of reality. This interaction might not just be a theoretical quirk of physics, it could be a fundamental feature of how quantum systems work. As we start to think about the implications of quantum computing, the concept of multiple universes becomes less a matter of science fiction and more an exciting frontier of scientific possibility. If quantum computers are capable of tapping into quantum states that exist in other realities, there could be an entirely new form of communication and computation on the horizon. Instead of merely processing information from our own universe, these machines could open up a direct line to alternate versions of events, alternate timelines, or even alternate civilizations. The implications of such an ability are vast. What if we could solve problems by accessing solutions from alternate universes? What if quantum computers could provide insights from realities where different choices were made, leading to breakthroughs in science, technology, and even philosophy? Moreover, the idea of interacting with other universes opens up questions about the nature of reality itself. Are we truly alone in our universe? Are there alternate versions of ourselves living out different possibilities? And could quantum computing provide us with a bridge to these other worlds, allowing us to explore the infinite possibilities that exist beyond our own dimension? The idea that Microsoft's quantum chip could be communicating with multiple universes is without a doubt one of the most mind-bending and thought-provoking concepts to emerge from the field of quantum computing. While it remains a speculative and theoretical idea, it's rooted in the very fabric of quantum mechanics and could represent a new frontier of exploration. As quantum technology advances, we are only beginning to scratch the surface of what might be possible. Whether or not quantum computing will allow us to access alternate realities remains to be seen, but the potential is there. What we know for sure is that the future of quantum computing promises to be one of the most transformative chapters in the history of science, one that may challenge everything we think we know about the universe. As we continue to explore this new frontier, it's clear that we're on the cusp of something extraordinary. Whether or not we unlock the secrets of multiple universes, one thing is certain: quantum computing will reshape our understanding of reality itself. To wrap up, the idea that Microsoft's quantum chip is communicating with multiple universes is a fascinating and mind-boggling concept. While it's still a far-out theory, it opens the door to a whole new way of thinking about quantum computing and the potential of parallel universes. If there's one thing we know for sure, though, it's that quantum computing is going to change the world in ways we can't even begin to predict. And who knows? Maybe one day, we'll discover that we're not just using these computers to solve problems in our own universe, but to reach out and connect with others in ways that are beyond our wildest dreams.